For centuries, we looked at Neptune and thought it was unique, a strange, cold, blue giant at the edge of our solar system. But today, that view is shattering, because telescopes are revealing the truth. Neptunes are the most common type of large planet in the galaxy, and their existence is rewriting the story of how planets form. Picture this: you're an alien astronomer in a distant star system. You point your telescope towards a small, unremarkable yellow star, our Sun. And what do you see? Chances are, the first major planet you'd spot beyond the asteroid belt isn't a behemoth like Jupiter. It's a Neptune-sized world, a subgiant planet, and that's exactly what's happening when we look out. We are finding these ice giants around countless stars. They're so common that astronomers have a special name for them: Neptunian twins, or sometimes just sub-Neptunes. Their discovery was a massive shock. Our own solar system suggested a certain architecture: small, rocky worlds close to the sun and massive gas giants further out. But the cosmos had a different plan. The Kepler Space Telescope revealed that planets between the size of Earth and Neptune, these sub-Neptunes, are arguably the most common type of planet in the universe. So what exactly are they? Unlike Jupiter and Saturn, which are mostly hydrogen and helium, these worlds are thought to have a thick, massive atmosphere of hydrogen and helium surrounding a core of rock and ice. Hence the name ice giant, though the ice is less about frozen water and more about volatile compounds like water, ammonia, and methane that condense in the cold outer regions of a planetary system. The big mystery is, why are there so many of them? And here's where it gets really interesting for our own solar system. One leading theory suggests that our solar system did have more of these worlds early on. Imagine a young solar system bustling with dozens of small, Neptune-sized planets. But gravitational interactions, a kind of cosmic pinball, sent most of them crashing into the sun or being flung out into interstellar space. What we see today, just Uranus and Neptune, might be the lonely survivors of a much more crowded neighborhood. In other systems, things settled down differently. Perhaps the orbits were more stable, or the planetary seeds formed further out, allowing these Neptunian worlds to survive in vast numbers. This is a humbling thought. It means our solar system's arrangement isn't the standard model. It might be an outlier. And this leads to an even bigger question: what does this mean for life? Many of these Neptunes orbit very close to their stars, so close they complete an orbit in just days. These are called hot Neptunes. They're broiling worlds with temperatures hot enough to melt lead, their thick atmospheres stripped away by intense stellar radiation. But others orbit in the habitable zone, the region where liquid water could exist. Could a Neptune-like planet host life? It's unlikely on the planet itself, as it has no solid surface. You'd fall straight through the atmosphere. But what about its moons? A large Neptune-sized planet could easily have a family of moons, some of which could be Earth-sized, with rocky surfaces and liquid water. In those moons, life might have found a way. Imagine a sky dominated not by one moon, but by a gigantic, blue-swirled Neptune-like planet. That could be the reality for life on countless worlds. So when we look at Neptune now, we shouldn't see a lonely sentinel at the edge of our solar system. We should see a template, a standard model for planetary architecture across the galaxy. Its haunting blue beauty isn't a rarity, it's a cosmic commonplace. And that changes everything about our search for other Earths. We're not just looking for pale blue dots anymore. We're looking for pale blue dots orbiting pale blue giants. The galaxy is filled with Neptune's twins, and their story is only just beginning to be told. Does it blow your mind that Neptunes could be more common than stars like our Sun? Let me know your biggest "what if" about these worlds in the comments below.